In this DVD I'm going to be working through question 11 from this paper. It's a foundation level paper from 2011 from mathstutor.biz and mathsdvds.co.uk. So not only will I be working through this question 11, I'll give you the marks that are awarded and where they are awarded. If you want your opportunity to work through the whole of this paper and have your own copy, and also paper 1 and the DVDs that work through all of the questions on those two papers, then you can get full details from mathstutor.biz or mathsdvds.co.uk. Now question 11 contains all these triangles, but as you can see there's not enough room for the questions as well, so let's have a look at the questions. The first one says, which triangle is an isosceles triangle? Now take care. This looks like it's an isosceles triangle because it looks like those two lines are the same length. Now you can get a ruler and measure them, or in fact you could use counting squares. 2, 4, 6, 8, 2, whereas this is 2, 4, 6, 4. So that line's not the same length as that. Or you could use a ruler, same as this one. This looks like it's isosceles, but if you measured those two lines, they're not the same length. It's actually this one here. This is definitely going 2, 2, and this is going 2, 2. So the isosceles triangle, the triangle with two equal sides, is C. Part B. Give the special name for triangle H. There's triangle H. It's a right-angled triangle because it's got a right angle in it. Right angled triangle. Which two triangles are congruent? Now what does this word congruent mean? It actually means exactly the same in every respect. Same length of sides, same angles, same triangle, but in a different place. So which two triangles are exactly the same? A quick glance, you see those have got the same angles. That angle's the same as that, that angle's the same as that, that angle's the same as that, but they're not exactly the same. We call those similar. Similar because they have the same angles and the sides are in ratio. So that's another word we should know, but not for this particular question. We're looking for congruent. So if we look at the triangle B and G, you'll see that this side goes 4, 1 and this side goes 4, 1, so they're exactly the same. This one goes 2, 3, this one goes 2, 3, so those two sides are exactly the same, and this one goes 2, 2 and that one goes 2, 2. You could use a ruler and measure them, but the way I've just sort of done the counting is actually more likely to get you, well, I think it's easier. So it's B and G, so let's write that down before I fall over my own tongue again. Triangle A is an enlargement of triangle B. What's the scale factor of the enlargement? So as already said, these two triangles here, A and B, have the same angles. So this is an enlargement of this, and this is an enlargement of that, even though it's got smaller. That's an enlargement getting smaller, that's an enlargement getting bigger. Because in mathematical terms, we still call it an enlargement. And the two triangles are similar, and the question says, what's the scale factor of the enlargement? Well, this line here goes 2, 3, and then 2, 3 again. Whereas this one just goes 2, 3. And you can do the same sort of counting for this side. That goes 2, 4, 2, 4, 2, 2. So that's twice as long as that. So it's an enlargement of scale factor plus 2. You can just put 2. You don't have to put plus 2. By the way, coming back to the diagram, the enlargement going this way, where it's getting bigger, which is what the question asks for, is an enlargement of scale factor 2, whereas going this way, as I say, from A to B is still called an enlargement, but it's an enlargement of scale factor 1/2. Not that you need that for this question, but one of the points of doing practice papers and past papers is to revise as many things as you can, not just the particular question itself. So what is the marks here? 3 marks. 4. 1, 2, 3, 4 marks. 1 mark for each of the answers.